All right, in this video, we are going to be solving and graphing linear inequalities. All right, there is basically the same process here that what we did in the other video for when we were solving equations. There's just one extra step, so write this down on your paper. Anytime you multiply or divide by a negative, oops, getting kind of messy, a negative number, you have to flip the inequality. If you multiply or divide by a negative, less than will become greater than will become less than. You flip the inequality. Okay, make sure you have that rule written on your paper. Okay, let's do this warm-up. So for my warm-up, I am going to combine like terms. Look, everything over here is already on the same side, so I can just combine it like it is. 3x plus 5x is 8x. Minus x, remember that's the same thing as minus 1x. 8x minus x is 7x. And 4 plus 7 is 11, combining the things that are like each other. Now my goal when I'm solving equations is to get the variable by itself. So I'm going to subtract 11 because plus 11 and minus 11 are opposites. They cancel out. And then I'm going to divide by 7 because times 7 and divided by 7 are opposites as well. All right, now if I wanted to check and see if my answer was correct, if this is the quiz day or the test day, I can substitute in 11 for every one of my x's all the way across, and then I can work out what I get. And if it works out to be 88, then I got it right. If it works out to be something other than 88, I'll know I made a mistake and I can go back and fix it. All right, let's do one more. I see here I have some like terms that I need to combine. Negative 1 plus 31, well, that's 30. Positive 30, because 31 is bigger than 1. All right, now let's work on getting all of our variables on one side and all of our constants on the other side. It doesn't matter which one you choose to put on the left and which one you choose to put on the right, as long as you separate. So 8a minus 1a is 7a. Positive 2, negative 2 cancel out. Positive a and negative a cancel out. 30 minus 2 is 28. So you can see I've separated my variable terms, away from my constant terms. Now, still trying to get a by itself, I've got to divide by 7 on both sides, and I get 4. And just like before, I could choose to go up here and substitute in 4 for both of those and check and see if I got the right answer. All right, let's move into inequalities. We're going to basically do this the same as equations. That's why we practice those first, with the exception of that one step that I asked you to write on your paper. So let's work to get y by itself. All right, I'm going to add 9 to both sides because positive 9 and negative 9 cancel out. And I'm going to divide both sides by 11. Y is greater than 2. Okay, so let's graph what we have here. I'm going to choose to put 2 and then just one number on either side. You can choose to go down to 0. Some teachers maybe will ask you to label 3 or 4 numbers on either side. Whatever your teacher wants you to do or whatever the computer program asks you to do, just follow the directions. For me, I just want to see the one number that's part of the answer and at least one number on either side of it. Okay, so y is greater than 2. That means 2 is not really included as part of the solution. 2 is not itself greater than 2. So that means I'm going to put an open circle on 2 to show that it's not part of the solution. The numbers that are greater than 2 are to the right of 2. So I'm going to shade to the right. To help you remember that, you may want to put on your paper greater than goes to the right. I got that R in both greater than and right. Greater than goes to the right. Okay, another way you may choose to shade this, and it just depends. Computer programs ask for different things. Teachers ask for different things. I know the computer program that we used at Winthrop did not allow for open circles or closed circles. Instead, it wanted parentheses when things were not included. That doesn't change the fact that greater than goes to the right. We're still going to shade all the numbers bigger than 2. It's just that the symbol that goes on to show that 2 is not included is different. A parentheses or an open circle mean the same thing. All right, let's try this one. 7x plus 9 is greater than 10x minus 12. So I'm going to choose to subtract 7x from both sides. I could just as easily have subtracted 10x. I'm just going to choose to do 7x because 10 minus 7 is positive 3, and sometimes positive numbers are easier to work with. All right, let's add 12 to both sides. Working to get x by itself. That's a 21. All right, divide both sides by 3, and I get 7 is greater than or equal to x. All right, notice this time that the x is on the right-hand side. I'm going to choose to swap the x and the 7 because it's easier to graph if your variable is on the left-hand side. Now look, notice that the open part is going towards the 7 and the pointy part is going towards the x. So when you turn it around, that has to stay the same. The open part toward the 7, just like the open part was toward the 7 here. The pointy part is to the x, just like the pointy part is to the x here. Basically, this is saying if 7 is greater than x, then x must be less than 7. It means the same thing. All right, let's put that on our number line. I'll put some values on either side of 7. All right, this time 7 is included. You see the equal to right there? 7 is part of the solution, so I'll put a closed-in circle. And less than, the numbers that are smaller than 7 are going to go this way. A helpful thing to remember that is that less than goes left. All right, so you might want to put that on your paper as well. Less than goes to the left. All right, just like with the ones that are not included, the ones that are included have a different symbol that you could use as well. So instead of putting a closed circle on the dot like we did before, we might choose to put a square bracket. Square brackets and closed dots both mean that that 7 is part of the solution set. It is included. Now, if you look at it, this has infinitely many solutions. Every number less than 7, fraction, decimal, everything, whole number, integer, is less than 7, it's part of the solution. 7 is one of those numbers that's part of the solution. But over here, 8 that's not shaded in, 8 is not part of the solution. 8 is not part of 7. And there's infinitely many numbers over here also. So I have infinitely many numbers in the solution and infinitely many numbers not in the solution. All right, let's try this one. Negative 10x plus 4 is less than 54. Trying to get x by itself. So I'll work to move things away from the x. All right, now I'm dividing by a negative number. So look at what you wrote on your paper at the beginning. What do we need to do because you're dividing by a negative? You need to flip the inequality. So it used to be less than, and now it's going to become greater than because we divided by a negative number. We're going to flip the inequality. All right, let's graph that one. Remember, negative numbers go backwards on the number line as they move away from 0. Okay, I don't see an equal to line there. So on negative 5, I could put an open circle. I could put a parentheses, whichever the program asks me for. And greater than goes to the right. I remember writing that down before. Greater than goes to the right. So there is my solution. Again, I have infinitely many numbers in the solution and infinitely many numbers not in the solution. This time, negative 5 is not part of the solution because there's no equal to. All right, this time we've got a fraction. Do you guys remember how we solved these with the equations? We practiced this in class, where you multiply both sides by the denominator. So those 4's are going to cancel out. 3w, 4 times 4 is 16. So 3w is less than or equal to 16. Let's divide by 3. 3's cancel. All right, now at this point, about half of y'all are in a panic. You think we got it wrong because we got a fraction. But you know what? Fractions are fabulous. They're part of the answer. And they're totally good. You guys have matured enough that we need to start being comfortable with some fraction answers. All right, so if I were to change this into a mixed number, 16 thirds, that's equal to 5 1/3. Or if I wanted to write it as a decimal, I could write it like that. Either way, that number is in between 5 and 6. So here is 16 thirds, or 5 1/3, or 5.3. This time it is included because I see an equal to, so I could put a closed-in circle. I could put a bracket, and less than goes to the left. So I'm going to shade to the left. All right, let's do another one. All right, this time I have a fraction on this one as well. So I'm going to multiply everything just like before by that common denominator of 2. These 2's cancel out. Negative 1x minus 10 is greater than 4. Okay, let's try to get x by itself. So I'm going to add 10 to both sides. Negative 1x is greater than 14. Okay, I need to divide both sides by negative 1. All right, what did you guys write down? When you divide by a negative, what do? You flip the inequality. I've got negative 14. All right, negative numbers, remember how to put those on the number line. Moving away from 0. All right, this time I just have less than, not less than or equal to. So I'm going to put an open circle or maybe a parentheses, depending on which computer program I'm using, what it asks for. And less than shades to the left. All the numbers less than negative 14 are to the left of negative 14. All right, let's try this one. 5x minus 3 is less than negative 7x plus 21. Okay, I'm going to choose to put my variables on the right just so I can practice with that again with you guys. So those will cancel out. Negative 7 and negative 5 make negative 12. Subtracting 21 from both sides, trying to get x by itself. All right, now watch what happens here. I'm going to divide by negative 12. All right, I divided by a negative number, so I have to remember to flip my inequality. That less than becomes greater than. 2 is greater than x. So it doesn't matter that my answer is positive. That's not what flips it or doesn't flip it. It's because the thing I divided by was negative. All right, and then remember, we don't like to leave it this way. We don't like the variable to be on the right. We want to flip the variable around to be on the left. The open part is to the 2. The pointy part is to the x. So that has to stay true. Pointy part to the x, open part to the 2. All right, let's put that on our number line. All right, x is less than 2. That means I need an open circle because 2 is not included, or maybe I need a parenthesis if I'm using a different program. And I'm going to shade to the left because all the numbers less than 2 are smaller than 2, and they are to the left on the number line. So how many answers do we have for this particular question? We have infinitely many answers. Everything shaded over here is part of the solution set. So we have infinitely many things that are part of the solution. We have infinitely many things on this side that are not shaded that are not part of the solution. How about 2 itself? Is 2 part of the solution? Nope, because there's no equal to. All the things that are less than 2 are part of the solution, but not 2 itself, because 2 is not less than 2.